let's do it. Let's take a look at problem two. So problem two is another fun problem involving unit conversions, although it's a little more tricky in that it involves, logarithms, and so we're going to have to remember some of our log rules. And so we're told the equation below gives the boiling temperature of isopropanol as a function of pressure, where T is in Kelvin, P is in bars, and parameters A, B, and C are given below. So you've probably seen the Antoine equation in the past, where log P is equal to A minus B divided by T plus C, where for a given temperature, you would compute the corresponding saturation pressure. Here we've just rearranged it, so we've solved for T in terms of P. All right, and so you can think of this as I'm going to input. So I have a function where my input to my function is pressure in bars, and my output is going to be temperature in Kelvin. So A, B, and C really don't have units. What's important when working with our Antoine equation is the units of P and T. Right. So in this case, for a given P, this is going to be your units of T. And what we're asked to do is to take that equation and tweak it so that we get a final equation that looks the same. Only now we'll use temperature in degrees Fahrenheit, P in PSI, and then instead of log base 10, we're going to use natural log. Okay, so we're going to get an equivalent expression where instead of log base 10, we have natural log, or log base E. All right, log base 10 is typically what you think of as just log is that standard convention. And then A, B, and C, now primes are constants related to A, B, and C. So when I give P as an input in of pressure in PSI, out it's going to be temperature in degrees Fahrenheit. Okay, so let's do it. Let's give it a try. All right, let's go all in. And so again, basically what we have, right, is given the equation. So T is equal to B divided by A minus log base 10 of P minus C, where in our starting equation temperature is in Kelvin and pressure is in units of bar. Okay, so what I'm going to do is I'm going to take my starting equation and I'm going to write T as a subscript in terms of Kelvin. P, I'm going to give it a subscript of bar to remind myself of the units. Okay, and remember again here, essentially we have a function where I input pressure in bars, out's going to come temperature in Kelvin. Okay, and I want to tweak this so that I can put in a pressure in PSI, get a temperature out in degrees Fahrenheit, and then also within the equation we want to change from using log base 10 to using log base E. Okay, so essentially we have three conversions: temperature, pressure, and the base of the log, and so essentially just got to go through it one at a time. So where we start is completely arbitrary and up to you. So I'll just guess, well, let's just start with pressure. Okay, let me start with converting pressure from bar to PSI. Okay, and so again, the picture to have in your head is right now I have a function where in comes pressure in bars, out comes temperature in Kelvin. I want to change this so that in comes pressure in PSI. So if I were to input a pressure in PSI, you can think of it as converting it to bars, so that in the form right now, still outcome would come temperature in Kelvin. Okay, so in order to do that, I'm going to have to look up my conversion factor. So if I go to the appendix of my, it wasn't the appendix, so the scanned up appendix, it's in chapter 1. So from table 1-2, when dealing with pressure, here we have the conversion right there. Okay, so we're told that 1 psi is equal to 0.06895 bars. Okay, so kind of using the same notation of subscripts. So pressure in psi would be 0.06895 times my pressure in bars. Okay, cool. Okay, so before I plug it in, all right, we're going to exploit two log rules, right? And so before I lose you, so log rule 1 will employ is if I have the log, the product of two quantities, say A times B, remember I can write that as log base, or log of A plus log of B. All right, so I could take multiplication. I'm going to rewrite it as the sum of the corresponding logs. Okay. The second thing I'm going to use, okay, is if I had, say, the log of 1 over A. Okay, log of 1 over A is equivalent to the log of the inverse of A, or A raised to the negative 1 power. Okay, and so that's just going to be then equal to negative 1 times log A. Okay, so log of 1 over A is equivalent to negative log A. Okay, so putting it together, okay, so coming up here, so starting with our original equation, so TK is equal to B divided by A minus log base 10. Okay, well, P in bars, okay, so I guess I should have taken it a little further. So taking this equation and rearranging, P in bars is equal to 1 divided by 0.06895 times P in PSI. Yeah. So plugging this into our original equation, I have B over A minus log base 10. P in bars is 1 over 0.06895 times P in PSI minus C. Okay. So then, I can take the product of these two quantities and write it as a sum. I have TK is equal to B divided by A minus log base 10 of 1 over 0.06895. And actually, let me put parentheses in here so I make sure I get the sign right. So log base 10 of 1 over that plus log base 10 of P and PSI. All that minus C. Okay. Now remember, log base 10 of that inverse, I could just write as negative log base 10 of 0.06895. That's plus log base 10 in PSI. Okay, and all that minus C. All right. And yeah, the minus C is not included in the denominator. All right. So TK, okay, is equal to B divided by, okay, now let's distribute through A. So negative, negative, this is plus log base 10, 0.06895 minus log 10 of P and PSI, okay, minus C. All right, so A, B, and C are constants. Log base 10 of 0.06895 is just a constant. And so what I'm going to do is I'm going to define a new constant. Let's call it A1, okay, because I'm not sure if we'll end up adding anything else to this quantity quite yet to go to A prime. So I'm going to define A1 as being A plus log base 10 of 0.06895, right? Just as I try and keep track of things. So I'm going to write this as TK is equal to B divided by A1 minus log base 10 of my pressure in PSI minus C, where I've defined A1 as being A plus log base 10 of 0.06895. Cool. The first part of it. All right. So now, since I'm started playing with p, let's just keep playing with p, and let's work on changing the base of our logarithmic expression. So we're asked to use natural log. Again, here we have log base 10, which you've probably just seen using the convention of LOG in your previous classes. So remember, natural log is nothing more than log base e. Okay. All right. So it's just a matter of the two most common logs that you see are log base 10 and log base e, and so that's where we get this shorthand notation of just log, log, and ln. Okay. All right, so in terms of change of base, the expression to remember, and if you can't remember it, please know I have to look it up all the time, pretty much any time I see it. Where's my cursor? Oh, come on, I lost my cursor. Here we go. Is going to be log base b of a is equal to log base x of a divided by log base x of b. Okay, so how do we use this? Well, we could define x as either being 10 or e, and we'll get the same answer. But let's just say, since I want ln of p, let me just write this then as log base e of p in psi. Okay, where again, as an aside, log base e of x is just ln of x. Okay, so log base e of p in psi. So b is e, a is psi, is equal to, okay, so what I'm going to use for x is going to be 10, right? It's just this numerator and denominator need to have the same base. I'm going to use 10 since we're starting with log base 10. So that's going to be log base 10 of a. Well, a is psi, as we've written it, divided by log base 10 of b. B is e, right? And e is just a constant. It's a number. Okay. Whew. So what I end up having then is, remember, log base e is natural log, is log base 10 of e times, I'll rewrite as natural log of p in psi, is equal to log base 10 of my pressure in psi. So if I go back up to my expression, I could take log base 10 of psi, and I can substitute in this. All right, and so I'm going to substitute this in for log base 10 of p in psi. So that gets me the temperature in Kelvin is B divided by A1 minus log base 10 of P in PSI. I replace with log base 10 of E times natural log of P in PSI, and then all that minus C. So, this equation is fine as is, but if I go back to the, problem statement, it tells you that essentially wants, an expression equivalent or similar in form to our original equation, and so there's no constant times ln p, it's just ln p. All right, and so while log base 10 of e is just a constant and is perfectly fine, it wants it kind of in that conventional Antoine form. All right, so how do I get rid of log base 10 of e here? Is we use our favorite mathematical trick. So our favorite mathematical tricks are always multiplying an expression by 1, because 1 times anything is that anything. The second mathematical trick that I'll say is our other favorite mathematical trick is adding 0, right? Because anything plus 0 is that anything. Okay, so how am I going to multiply by 1 here? So tk. Okay, so I am going to multiply my expression here by 1. Okay, so I'm going to multiply by log base 10 of e divided by log base 10 of e. Okay, so log base 10 of e divided by log base 10 of e is just 1. So times b divided by a1 minus log base 10 of e times natural log of pressure and psi. Okay, all that minus c. Okay, and just for clarity, I'm going to further rewrite it as tk log base 10 of e divided by log base 10 of e. I'm going to rewrite this quantity as 1 over log base 10 of e divided by 1 over log base 10 of e times b divided by a1 minus log base 10 of e times natural log of p and psi. All right, just so I can make it clear exactly what I'm doing. Okay, so then next we'll distribute through. Okay, so tk, so 1 over log base 10 of e times b. Okay, so I'm going to have b divided by log base 10 of e divided by a1 times 1 over log base 10 of e. This is a1 divided by log base 10 of e minus, well, log base 10 of e times ln psi divided by, or times 1 over log base 10 of e. The log base 10 of e's cancel, and I'm left with just ln of p and psi minus c. Okay, so log base 10 of e is just a constant. Okay, so I'm going to define two more constants, so kind of using the same convention. Let's just use a subscript 2 to be consistent throughout. Let's call b2 is going to be defined as b divided by log base 10 of e, and let's define a2 as being a1 divided by log base 10, right, of e. Right, and you just need to keep track of all these constants as we work through the problem, right? But log base 10 of e is just constant. E is just a number. Okay, so where does that get me? Well, then at this point I have tk is equal to what I've called b2 divided by a2 minus natural log of p. I'll just write as natural log of p and psi minus c. So I'm almost there. So now I have an input of pressure and psi. I have natural log instead of log base 10. But the missing piece is this still gives me temperature in Kelvin. I want temperature in degrees Fahrenheit. Okay, so what I'm next going to need to look up is our conversion for temperature. Okay, so if I go back to chapter 1, temperature is not in the table, but there is a section on temperature. All right, and so here's a conversion from Fahrenheit to degrees C. Then we have Kelvin to C, Rankine to Fahrenheit. So we can convert these equations however we want. We can go Kelvin to Rankine, and then Rankine to Fahrenheit would be fine. We can go Kelvin to degree C to Fahrenheit. All would do exactly the same. Let's go Kelvin to Rankine, and then Rankine to Fahrenheit. And so if I were to go that route, so my temperature in Kelvin, temperature in Kelvin is 1.8 times, so they write it as, 1 Kelvin is 1.8 Rankine. So temperature in Kelvin is 1.8 times my temperature in Rankine. Okay, so that gets me Rankine. Now how do I go from Rankine to Fahrenheit? That's here. So my temperature in Rankine is equal to my temperature in Fahrenheit plus 459.67. Okay, cool. So if I were to plug that in here, then my temperature in Kelvin is equal to 1.8 times temperature in Fahrenheit plus 459.67. Okay, so if I plug that in here, I have 1.8 times my temperature in Fahrenheit plus 459.67 is equal to our B2 divided by A2 minus log and PSI minus C. Okay, and so now I just want to massage the left-hand side of this equation so that just TF is remaining. Okay, so for starters, I'll go through and I'll divide through by 1.8. Okay, so that would give me then TF plus 459.67 is equal to B2 divided by 1.8 divided by A2. Actually, no, I'm messing up my math a little bit, right? Because it's just divide through by 1.8. It's just 1 over 1.8 times this quantity, and so I could just leave it up top. So B2 divided by 1.8. I'll just keep the denominator as A2 minus log PSI. All right, so it's 1 over 1.8 times this quantity, and I'll just group it up in the numerator because I know I'm going to try and group these and defining new constants. So that'd be C divided by 1.8, and then I need to bring over the 459.67. So T in Fahrenheit then, TF would be equal to B2 divided by 1.8 divided by A2 minus log, natural log of pressure in PSI, minus C divided by 1.8 minus 459.67. So that in terms of the last step of things, we'll define a new constant B prime, which is B2 divided by 1.8. You can see how B2 is defined above. A prime is just going to be A2, that last definition of the constant. And then, looking here, okay, C over 1.8. So 1.8 is just a constant. 459.67 is just a constant. So we'll define C prime as being, let's see, I need to be careful because I want minus C, right? Minus C. Sorry, so coming down, so I want minus C. So what am I going to do here? So I want minus C, and so all I've got to think. So C then is going to be original, or C prime is going to be C divided by 1.8 plus 459.67. Yeah, so it's the, so just let me write it down so I can, so TF then would be B prime divided by A prime minus ln, natural log of pressure in PSI, okay, minus C prime, right? So this is right because it's minus C prime. That'll give me the negative C over 1.8 minus 459.67. Phew! All right, so check. I've got my final equation. Here I define my constants. So you could go back up and plug in A2 and B2 in there, and then ultimately with A1 or A2, you'd have to plug in A1 to get it all the way back to A prime or to A. But there you have it, right? So key was just go one step at a time. This one just has a couple extra wrinkles compared to problem 1, and that we've got to deal with logarithm here. Okay, hopefully you can get that. If you have any questions, just let me know.